Hey guys, welcome. I don't bite, so you can move forward, if you will. I promise not to bite. Thank you for taking this time this morning and attending this session. I know you have a lot of alternatives here at PASS. So today we're going to look at SQL Server on Linux and lessons from some early deployments. I've been working with Linux for the last 8 months to a year now and have seen customers go to production before we GA'd, and we're excited to bring this release out to the market. So my name is Denzil Ribeiro. I'm a principal program manager in the Azure Customer Advisory Team, or SQL Customer Advisory Team. So we are part of engineering which focuses on customers and help them deploy before we GA and collects. We are the voice of the customer to the engineering org. So we help in deployments, collect feedback, translate that into priorities, so on and so forth. So today, some formalities, please silence your cell phones, though this room is big enough, I think, that I wouldn't hear it if you are back there. From an agenda perspective, we'll spend a few minutes, not too much time on architecture overview. I'm sure you've seen some sessions. How many of you have actually played with the product so far? Okay, good chunk of you. So we'll look at some architecture overview of how this was built, but not spend too much time on it, and we'll spend most of the time in more practical scenarios. And when I say install, we're not going to look at like basic installation. We'll look at unattended or offline installation. We'll look at some troubleshooting from a configuration perspective, performance, how do you monitor performance, and look at some advanced topics in terms of X events and how to collect call stacks and come up to root cause of problems. How many of you have Linux experience other than SQL? Okay, so fair amount of you. So let's get started. So from an architecture perspective, SQL code is pretty much the same, whether it's on Windows, on the cloud, or on Linux. So the code, code for SQL Server doesn't change. So what we have in this release is the database engine and integration services. The BI stack isn't available on the Linux platform. And how we made this possible is using this platform abstraction layer. So what is this SQL PAL, or SQL Platform Abstraction Layer? Effectively, what we did is we took the NTOS kernel and put it in user mode. We stripped it out of the ring 0 type services, which are things like page table and such. And so we could be able to only have to implement 45 to 50 APIs or ABIs in order to support what is needed out of the kernel in user mode, right? And those APIs then are translated to this HE or talk to the host extension layer, which maps it to native Linux calls. So things like thread management, memory management, debugging, streams, just 5 classes of operations are actually supported there. So for system and latency sensitive code paths, we go through this layer called SQL OS. SQL OS has been around since SQL 2005. Now, SQL OS has some, direct APIs which talk to this host extension for things like I/O, which is latency sensitive. For the rest of the stack, we go through the NTOS, which is in user mode, and the normal API, calls that we would do. So for things like XML, if XML calls a Win32 API, it'll go through the same code path, if you will. So what is the process look like? Because I'm trying to make this practical. So since we're a small audience, if there are questions, please feel free to let me know. I tend to talk fast, so if you need me to slow down, please let me know. So from the process structure perspective, when you look at the service itself, you see 2 processes, which is kind of different. If you look at Windows, you see just one, right? So you have one of the process is a native Linux process called the monitor process. And his work is effectively just to spawn a child process and listen to him and monitor him, see if there are exceptions. On exceptions, they will invoke something called a core dump, so on and so forth. He's not the actual SQL code that runs in the engine. And then you have the second process, which is actually effectively the SQL Server process, if you will. So what that looks like is this section, which is the SQL PAL and SQL Server, is effectively this blue one. And then you have the HE and the monitor process is effectively just a monitor which monitors that. So there are two processes. Now, if you install agent or if you install any of the other packages which we'll talk about, you don't get additional processes. They still coexist in the same SQL Server process, if you will. So from a repos perspective, we have split the install up into 5 parts now. So you have SQL Server, you have agent, you have full text HA, and IS, which is integration services. So each of these needs to be installed separately if you need it or not. There's no wizard. It's all native installers from Linux perspective. You know, you have a folder structure. The binaries are pretty much a fixed folder at this point. So you have OPT MS SQL, which is this path, you know, which has all the libraries. As you can see, we don't have too many files. You don't see SQL Server.exe or SQL Server.dll. Or anything of that sort. And the reason why is these files are actually bundled into something called a single file package or an SFP. Think of SFP as actually just a container for a bunch of files. Inside the files, you know, you would see, if you crack open the SFP, you would see the DLLs and the executable, so on and so forth. And what is done when SQL Server starts up is that SFP is loaded, and it's used just like a memory mapped file. So if I brought up strace, you would see the SFP being loaded, and you know, the DLLs are at fixed offsets or known offsets, you know, from the start of the file. So the SFP has kind of a, you know, mapping table with offsets. So that's the SFP stuff. And then data and logs by default go to var opt MS SQL, right? So that's something you potentially want to change, you know, based on best practices, you know, for SQL. And we'll look at some of that. So, and there are some hidden folders like .system. If you actually crack open .system, you'll see familiar things that you would see on the Windows OS, right? Program data, .NET, you know, net framework. You'll see even a C:\, Windows somewhere there, if you actually, you know, look at that hidden folder, .system. And the reason, again, is we trick, I mean, the code is the same, right? So there has to be a registry, if you will. There's no registry natively in Linux. So we have the read-only, you know, part of registry which exists there, so on and so forth. So you'll find familiar Windows folders. They're hidden from you. You know, practically, you can't change them or do anything with them, per se. More on the practical side, we'll look at install. So install is via native installers. So you have apt-get, or you have yum, or you have zipper, depending on the distribution. We support you know, SLES, RHEL, and Ubuntu today. And the install is in 2 steps. You install, and then you configure. We're not going to look at the base install too much. The key, which is going to be a little different for you today, is this concept of repos, and where you pick up what bits depend on what repo is configured. So at RTM, we have the cumulative update repo, but say you run into a bug where you open a case and open a hotfix, and we issue an on-demand hotfix. That is going to go in a separate repo. So you'll have to change the repos, and I'll show you how to do that in a second, to get the right branch of software, if you will, right? So offline install, again, offline install is when you have a data center that doesn't have internet access. There's not going to be media per se, so you download it on a internet-facing machine. Most of the SQL packages don't have a ton of dependencies other than tools. Dependencies can be a problem, right? So if a package depends on another, when you download, it's not enough to just you know, download that package. So there are tools out there like Yum Downloader, which says resolve dependencies and downloads it into a folder which you can then copy on RHEL. Or apt-get download, you know, will work on Ubuntu. So there are various ways of actually downloading on internet-facing and then copying over. From an unattended install perspective, I've put a GitHub script which we'll walk through, which actually automates some of this install process, detects your OS, configuration, so on and so forth. So I'm not going to spend too much time there here because we'll do in the demo. And then there isn't any native multi-instancing. So multi-instancing is with Docker. So, you know, natively in Linux, I mean, an application has a named, known location path, so they followed the Linux, you know, best practices around that. So, multi-instancing is with Docker, run more than one container. One more slide. So when talking about Docker, there are a few best practices here. We'll go through a demo of Docker too. Docker, one of the main things is around storage and containers, right? So if Docker containers are used a lot in DevOps, CI/CD pipelines, so on and so forth. Mounting or having persistent storage for containers or for your data volumes, if you don't want to lose them when you shut down the container and start it, is important. So you can either mount a volume of the host or use Docker volumes, if you will, or you can use Docker volume storage plugins, which integrate Docker with storage subsystems such as Nimble, there. Couple other options which we'll see in the demo shortly. Capad's sys ptrace is a not very known option, but that allows a debugger to actually connect and take a dump or on an exception for a container. So if you don't have that option enabled for Docker, run command, if you hit an exception, we won't get those diagnostics that we usually get on the Windows side. From a supportability perspective, from orchestration perspective, Kubernetes and OpenShift are the supported platforms. And just for unattended install as well as Docker, a lot of the configuration can be done with this concept of environment variables. So what are they? You want to change your data folder or log folder. You want to change your collation or things of that nature. They can be passed as environment variables to the Docker run command, which in turn will actually configure the instance to be that way. So enough of talking. Let's go to a demo. So here I have let me just check. I just did a git clone of the repo which I have on the slide. So slides should be uploaded. I have some changes which I've made, so I'll re-upload it today. So SQL unattended will be my repo. So this repo effectively takes something called a configuration file. So if you think about the previous install thing, it just installs the binary, right? All your configurations are post-install, generally speaking. So this just facilitates that. So vi SQL unattended.conf is the configuration file that I've put together. This is just a sample. You can evolve it as you wish. It's free to download. So first step is configure your repos. So if you want to point to a different repo, all you do is change the repo in the config file, right? And it'll pick up the build that you want from there. Then you have a section, and it handles different distributions. So it handles Red Hat, Ubuntu, or SLAS. Then you have a section for environment variables. So things like MS SQL data directory, MS SQL log directory. If you want to point it to a different drive, at install time itself, it will actually take those into consideration. Password, the PID, if you want to have it as enterprise or developer or whatever, you can specify the actual PID there. Also, enables you to install various things and say, I want to install SQL Server agent or not, or I just want to install the engine, install HA or not. HA does have some prereqs, which you would require kind of an admin to do. So for example, on SLAS, you need a particular package installed on a subscription and so on and so forth. So as long the requirements are mentioned here, other than that, once those prereqs are there at the OS level, you can flip that switch to yes, and it would install HA as well. And then the second section of this is more of the smart configuration. So what we lack on the Linux side today is things like smart tempdb setup, right? So on Windows 2016, setup itself detects how many CPUs you have, configures the amount of tempdb files, so on and so forth. So this script also takes that into consideration. You can specify a tempdb folder, initial size, and it'll detect how many CPUs you have and spawn that many tempdb files, starting with 8. So that's the config part. And SQL CPU affinity, we'll talk in the performance section. We recommend that on Linux on bare metal systems. So if you want to set that to auto-configure, again, it'll affinitize every CPU effectively on the box. So let's go and run this thing. Okay, so, and while this is running, this will take a minute or so. It's downloading the packages and stuff. We'll look at the offline install. So offline install process is simple. I mean, you just get your binaries wherever you are. And then you do apt-get install dot slash am I not in the right folder? Why is tab not working? I definitely do not want to type that. I don't know why tab was not working. Oh, okay, that's why. Okay, so that will install offline too. While these are installing for a second, let's just look at the, okay, actually this is almost done installing. So multiple steps is done. It's downloaded the packages from the repos that we have configured, right? Installed the packages, then it did this configuration step that you otherwise have to do manually, right? Then it looks at, what else has been, so it starts SQL Server up right there. It configures SQL Server, applies the licensing pig that you had given in the config file, and then it looks at what else you had, asked it to install. So here in this case, it was SQL Server agent is also installed. Configures firewall rules for the port, that you have specified. So it changed it from 1433 to a non-default port. It will open that up on the firewall. Test connectivity, and then configures TempDB and all these other things that we've talked about in Smart Setup. So at the end of this, you should have systemctl status MS SQL Server. You should have a fully configured SQL instance. As we talked about, this is the monitor process. This is the actual SQL Server process. I should be able to come here, -s. And I am in, right? So, that's the configuration perspective. For the offline install or normal install perspective, it's two parts. You have to do this part. You install the thing, and then you have to configure it. And this is what normal install looks like. You pick your edition. I say developer edition, give the password. Okay. Always fun when you fat finger something. And that goes to the install. But that has not applied any of this, additional configurations. Everything else has to come through a configuration, utility. And you can step through the code. I'm not going to actually step through the code that there are functions to install on RHEL, on Ubuntu, so on and so forth. It's freely available. It's done in Bash. So it should work on any of the, platforms. So that's the, install, piece, if you will. Let's go back to the slides. So how do you configure this stuff post-install, right? So MS SQL Conf is the way. Actually, even during install, MS SQL Conf has a setup switch with which it does the actual configurations. You could technically have environment variables and run the setup, and it would pick up those environment variables, but it's not as comprehensive as maybe that uninstall script. So this is a replacement for SQL Configuration Manager on Windows. So any of the server-level configs that you did, things like enabling trace flags, setting ports, startup parameters, collation, rebuilding master, think of everything configuration for the instance comes from this. This is a set of Python scripts, so you can go through the actual Python code. It's in the opt-ms SQL bin directory. And gives you all this functionality. And the results of that, once you configure it, are just stored in a conf file. So you can, at any point, open that conf file and see what your settings are from a settings perspective. So database drives and permissions. When you install this, we do create an MS SQL account and group. and we ACL everything by this MS SQL account and group. So this is very important when you mount drives, when you bulk insert, when you backup, restore, things of that nature. The files have to have, MS SQL has to have access on these files. Today, this is not configurable to be a custom account. We've heard from enterprises that that's a need, from that perspective. So this is one that gets created on install itself. And there's this whole issue with paths, right? So we support both Windows paths and native Linux paths. And so how does that work? What does C:, actually mean on Linux? What that means is we map C:, right now to root. So C:/ data would be like root/data on Linux. The only thing that does not go in a custom folder is the in-memory generated DLL. So if you have an in-memory table which generates those DLLs under the covers, those still go under a fixed path, which is under var opt MS SQL. Rebuilding system database is a little different, and the way you do that is the command. And as we talked about, moving system databases for TempDB, MSDB, everything else is possible except for master. Moving of master will come soon. It's not yet in the product. But it's the same steps as you would do on Windows, alter database, add, modify files, so on and so forth. So a couple of things from a troubleshooting perspective, right? So on Windows, we're used to all these services being separate services. I can stop and start each service, and if there's a problem with agent, I can stop agent or restart agent. This is one significant difference on the Linux side. They're all part of the same process here. So there is no stop and start of agent separately than server. And so if you have some sort of problem with agent, you'll have to uninstall agent pretty much, to allow the server to come up, if you will. And on install of agent, actually, we detect whatever jobs are on MSDB. So it's not like you have to recreate your jobs or anything of that sort. On agent install, we'll go to MSDB and see what jobs existed and stuff, and agent just picks those up. So that's one thing. From a troubleshooting perspective, I mean, when SQL Server doesn't come up, all the switches that we use, -M, -C, starting on command line on Windows, you can do that on Linux too. It's pretty much the same. It's just the context is important, and we'll see that in a demo as to why. Roll back to previous version, that's another common question customers have. How do I roll back to a previous version? The rollback is actually super simple if the version upgrade doesn't actually upgrade your system databases, right? So if the database version, and many versions don't, there are certain versions that if the catalog changes, the version is bumped up. If you're not actually, the system databases are not being upgraded, so first of all, best practice, of course, back up all your databases before you attempt any of this, right? I don't want you to go there and have problems. But you can just uninstall the software and install the software, and it picks up master, as long as you don't touch the data files, don't delete the data files and stuff like that. It'll automatically go and pick up your configurations, your data files, just uninstall and reinstall the binaries, and it picks the rest, up, if you will. So that's an easy way from a rollback perspective to move as long as database version is not changed. And then here's some locations for logs, but we'll see some of that through some demo. So I'm going to cheat for a second and just try to remember what I was supposed to, okay, got it. Okay, system, CTL stop, MS SQL Server. Let me do that. So let's, CTL stop. Let's see actually starting it as an application perspective and some troubleshooting aspects of it. So cd/opt/mssql/bin. This is where, some SQL Server at least exists, right? You see SQL Server here. So I'm just going to do a /SQL_servr, right? Or better, we'll put some switches -m, I don't know. Right? So the server just starts up, as an application and in maintenance mode, right? Things that we would do on the Windows side. No biggie. You see the error log being thrown up. Exiting out of that is just a Control-C. Not a big deal at all. So I'm going to end out of this, if it actually allows me to. spawn another. Okay, there. So say I did some troubleshooting and I come back, right? Now I'm going to try to start this as a service. Okay, and I'm going to look at the status. And well, it says it's running, it's enabled, it's running, it all looks good. You have this, SPID, so on, so forth. I'm going to try to connect. And well, I can't really actually connect, right now. So what went wrong? How do I look at some of the, troubleshooting aspects, if you will? So I get a connection error here. And one more clue you'll see is, when you do a systemctl status, the first few lines actually are printed, and all we see is actually started Microsoft SQL Server Database Engine, and nothing really after that. So let's look at the log and stuff. So another command you can use is journal ctl -u SQL Server. Let's see if anything is there. I don't actually see much. This is an evaluation version, and that's really it, right? So let's look at the log now. So we'll go, our next troubleshooting step, of course, when SQL Server doesn't start, is to go to the error log. So let's go there. opt/mssql/log, error log. So let's open the error log here. So we have an error log, of course. It's 1655. Let's open vi error log. Oops. I think I typed it wrong. Error log. Okay, it seems like the last thing says it's, SQL trace was stopped due to server shutdown. That shouldn't be the case, my systemctl status shows, and well, wow, this is with the C-m that we used, prior. I just tried to start it up as a service, and, that's not the case. The last time is 1655 here, so let's get out of this. And look at the time here, and it's, 1658, so it's definitely not that. So let's look at the logs in itself. And there's something that stands out, besides the time frame. It's nowhere close to the time frame I started. It stands out that permissions here are different than the permissions in the rest, right? So I have root here, and MS SQL everywhere else. So first thing that we do on startup, what do? We try to rename the log, error log to errorlog.1, right? So here in this case, because I had started it as an admin or root, errorlog got ACLed as root. And now when SQL Server is starting up as MS SQL Service, it doesn't have permissions to actually rename that file because it's owned by root and not by MS SQL. So that's a problem. So be careful when you're touching files within the system folders and stuff of your permissions and what you're going to do. So let's fix this. We'll change ownership, -r, MS SQL. Right, so once we do that, systemctl restart MS, should come up. And yeah, so you see much more than just, the starting up the engine. So it's up now. SQL CMD should connect. Localhost -USA. You better connect. Unless I messed something else up. Okay, cat. Okay, that's why. My port is different, sorry. So localhost, 1444, -USA. Okay, I'm in. So I forgot I had a conf file with a different port. But the server has started. So effectively, anytime you're starting manually, do sudo or touching any of those files, do sudo -u mssql followed by the command. So opt mssql startup or whatever else. So that way you're starting on the context of the MS SQL account and not your own account and messing with permissions on something you might not have permissions later. So that's one part. So let's look at real quick at MS SQL conf. Since we saw this port thing, so where's this? You saw that all these settings are stored in MS SQL conf folder, right? So it's where opt MS SQL conf. Where is the tool itself? It's opt MS SQL, bin/MS SQL conf. That's your tool. So there's several things you can do. You can do set, unset, so on and so forth. So let's just look at some of the options. I'm going to do list just to show you what options exist. And you get a whole plethora of options. You get all the file locations, whether it's backup directory, data directory, so on and so forth. You get the memory settings. You get network type things like IP address and ports or certificates. You get agent configs also. If you have agent enabled, they are relevant. And telemetry config. So all that is changed actually through a CLI, if you will. So that's the MS SQL conf part. Let's move to Docker real quick. Make sure it's cleaned up. Okay. So first thing is I pre-downloaded the image just in the interest of time, but it would take me otherwise a minute and a half or so. So Docker images. I have Docker on my system. I have the latest 2017 latest image, which will corresponds to the latest CU, which is 2017 CU1. And I don't have any Docker instances running now. Docker ps-a. I don't have any Docker instances running. So let's look at how to run an instance and what are the important trace flags or Docker run commands. Sorry, run instances.sh. So a couple of things you see, here you see the Docker run command and you see the environment variables. Everything with the -e has an environment variable. You're accepting the EULA, you're giving the PID, you're giving the SA password, you're giving a port. This is port mapping. What this means is port 1444 on the host is mapped to 1433 within the container. So from an application perspective, you're connecting to 1444. And not changing the port in the container because that mapping takes care of everything. Then -v is mounting a volume. So what you're saying here is within the container, var opt MS SQL is mapped to mnt docker data 1 on my host. And that can be a mounted drive which I've mounted from my storage, SAN, my pure storage array or extreme IO array. Then H gives you a host name. This is the name of the container, and this is that pcap add systrace for debugging purposes, right? To enable the debugger to actually, take a dump on an exception. So I am doing two instances here. So I have two Docker run commands, and one is running on 1444, one on 1445. So let's look at what that looks like. So just like that, I have two instances, Docker. Two instances running, one on 1445, one on 1444. I can connect to either SQL CMD -s localhost, 1445 -USA. I think I gave it this wrong. Okay, select server name. And you see it's SQL Docker 2. It inherited that host name that I gave in the Docker run command. So any application could connect also with the machine name of the host, 1444. There is no browser service on the Linux side. So when you're talking about named instances, you still have to pass port. There's no browser resolution, if you will. So app is responsible for passing the port from that perspective. So that's one thing. You can look at Docker logs for a container. So Docker logs, SQL Docker 1. I think it is SQL Docker, yeah. Will give you, the error log or any log generated by that, container. you can actually get into the container. So Docker exec -it SQL Docker 1 bash. And I'm now within the container. So if I do a ps -eaf, I'm seeing the processes within that container, which you see the 2 SQL processes here. I'm not on the host anymore. My SSH session is within that container. So if I go to cd/bash/opt/mssql/data, this is the MDF, LDF files and the path that the container thinks they are on, right? But remember, we had mapped the volume, outside, folder to this. So let's get out of this thing. If I go to MNT, is where I map my local volumes. I have a Docker data 1 and Docker data 2. And from the host itself, since I'd mounted those volumes and mapped them, I can see all that data just from the host, right? The same, master MDF, LDF, files, if you will. So what's the advantage of this? Of course, you spin down the container. When it spins up, it just picks up, this database files and moves on with life. Cool. So that's configuration stuff. Yes, sure.
You connected by SA account. Can you connect as yourself?
Yes. Yes. So you can set up NT authentication is supported. You have to do a bit of work. I didn't have a DC and all in the setup environment, but yes, you can with Kerberos. So you have to use kutil and configure realmd and configure the Linux machine to be joined to the domain first, because that's important. And once it's joined to the domain, you can configure SQL Server to use NT authentication. Yeah, no. I mean, that's true of Windows too, right? So, yeah.
Can you use Docker Swarm because you're using a shared drive?
Uh-huh.
One container dies, another one.
Yes, so that's the thing. We support Kubernetes or OpenShift as orchestration, environments. The industry is moving more towards Kubernetes and OpenShift than is Swarm, but those are the ones we support in production. Now you can use technically for if it's DevOps or Dev, it doesn't matter. It'll work. Yep. So where were we? So performance troubleshooting. Let's look at performance troubleshooting. So I came from I did Linux like in my computer science. When I didn't have any gray hair and I was young and fit. Not the case. Neither is the case anymore. And so last year when I started on this project, I had to relearn some of the Linux or Unix that I knew, which didn't really stick. And one of the big things was perfmon. I mean, I struggled with the concept of, okay, how do I visualize some of these counters and everyone? So just run top or run this or run that, right? So we invested some time in actually looking at performance and how do it make sense for someone who's familiar, semi-familiar with the Windows platform, not super familiar with the Linux platform, so on and so forth. The good part is from a troubleshooting methodology, right? Your approach is pretty much the same other than some OS counters, which we'll talk about in a second too. The methodology is really the same. Identify the top resources being used, identify the queries using those resources, rinse and repeat, right? Tune, rinse and repeat. SQL tools work on the SQL side just fine. There's no fundamental difference. Yes, there are some slight nuances. Things like ring buffers don't report CPU time correctly yet. There are a couple small nuances which don't yet totally work. But for most part, query store works, DMVs works, activity monitor works, extended events. I mean, it's just your normal SQL engine. So even if you have a third-party tool, connecting to SQL and getting the SQL side of the house should be just seamless, from that perspective. Linux, on the Linux side, it was a little more challenging for me in particular because I'm a correlation type guy. I need to see charts and so on and so forth. So there are a bunch of command line tools which folks who have worked with Linux for a long time are super comfortable with. Or there are monitoring utilities like Nagios or CollectD or Telegraph, which allows you to actually, visualize. Here are some links to some of that. What we did from a CAT perspective, and Stephen is in the audience too, is put something together from a visual perspective, which you can now download on GitHub if you want to monitor, some of your SQL servers on Linux. So how that works, it's all a container-based solution. You just, pull the container down, or clone the repo and run a couple SH scripts to give, some parameters, which we'll see in a second. And then you have a monitoring environment for your SQL Server on Linux, right? It's not detailed drill down. Don't think of it as SQL Sentry where you drill into a blocking chain. It's very lightweight, low performance, but it allows you to see bottlenecks across the OS and SQL. Right, so you use collectd on the SQL Server side. Every SQL Server instance has to have, collectd and a container rather running which has collectd. And then Grafana and InfluxDB, which is a time series, open source time series database on the central reporting side. So let's look at what that looks like now. I'm going to actually, yeah. Oh, okay, I don't need that. I'm going to start a workload actually. Okay. While we start this workload, let's go and look at this thing. Can you guys see this all right behind? No, I need to zoom in. Okay, so on the SQL Server side itself, so once you pull the repo, you should have something like this code. And it's as simple as vi run.sh configuring a, oops. It's not run.sh, I thought it was. cd collectd. It's as simple as actually taking a few parameters, and pointing, the credentials and, pointing this to an InfluxDB which actually has your, monitoring data, if you will. So pull and run, so docker ps -a on the SQL Server side will show you a collectd container running, if you will. And then on the central server, which is now holding data for these multiple instances which are monitoring, you will see two containers, if you will. Collectd is actually because it's monitoring the local one. The InfluxDB, which is the time series database, and the Grafana, which is more of the visualization layer. So what does this actually get you? So it gets you some charts like this. Actually, I'm going to go to my local desktop, which might be better resolution. So it gets you some charts like this. So you have the, OS performance counters visualized. So you have, CPU, memory usage, load, queue length, some of the memory taken by the SQL process, and disk, reads and writes, and so on and so forth. So it's a high-level view of how the server is looking, right? So, and then you get a SQL dashboard. So you can, flip through servers, so on and so forth. And then you get a SQL dashboard, which actually gives you more of your SQL performance counters. So there are two parts to this. We just ran two lightweight queries, right? sys.dmos performance counters. We pull a couple performance counters. And we look at sys.dmos wait stats. Just two queries, every 5 seconds, run. And even for a subset of, counters. So as you can see, transactions per second, I was doing about 15K transactions per second, and they just, tanked after that. I see that the reason is page latch IO is quite a big part of it, right? That's my main weight, if you will. If I sort by average, that's my bottleneck in this case, right? I can see wait statistics in terms of not only duration, but how many tasks are waiting. One thing you'll notice here is during a ramp up of a server, you'll see some memory allocation ext waits. You're not going to be able to do much. There's no locked pages in memory today on Linux or the equivalent. But these are small. If you look by the wait duration, it's not appearing anywhere close to. It's 87 milliseconds, which is negligible. And then you have other perfmon like counters. So this should be a start from a monitoring perspective if you don't have anything on the Linux side. So I'm going to stop that workload before. Okay, it's done. Okay, so move on, and more important thing are some best practices around this, and we'll see another workload and how this can actually matter. So, for those who have done SQL on Windows, I mean, we had a, pretty good pre-deployment I/O best practices paper, test your I/O, make sure your throughput is there, latency is there. So similarly, you can do similar things with the Linux environment, right? Whether it's using iometer or DDoFIO to test different patterns. Instant file init is enabled by default. This is more of a reference slide for you, if you will, in terms of options, right? So we've documented some of this, the individual settings portion at least in the docs. So it's not like just on a slide, it's there on official docs. So besides the IO settings, individual settings matter quite a lot. On Red Hat Linux, they have this whole concept of tuned profiles. And so they have, just like you have power plans in Windows, I mean, they have it's more than just a power plan. So they have, different settings encompassed through a tuned profile. But if you don't have, RHEL also on Ubuntu, you can do the same thing. Just you'd have to know what settings tune profile is used and actually use, something similar. So we recommend the throughput performance profile on RHEL. Power management is big again. I mean, just like it is on Windows. Make sure you set it to high performance on BIOS. And then, there's instructions in the article on C state and P state or controlling P state. The difference is just because you disable on the BIOS doesn't mean on the OS it doesn't, C states are not enabled. They're enabled actually by default. So be careful of that. A common question is, do I have transparent hues pages enabled or disabled? Other database systems recommend them to be disabled. As of this point, we say leave THP enabled because that's what we've seen, perf be best with. Then there are other couple, nuances. Linux by default has this concept of NUMA load balancing, which is enabled by default. So the OS can actually take your process and say, you want NUMA node 1, I'm going to put you on NUMA node 2 because there's less load there. Well, but we do memory allocations. We are a NUMA-aware application, so our memory allocations and access patterns are banked on the fact that, we'll put you on a NUMA node where we allocated, stuff for you. So we don't want the OS to actually move us because it causes some unpredictability. And, some of these other sets, so, and the other one is virtual address fragmentation. There's a default which is 64K. If you go over 64, think of this like page table entry table, right? So if you go over 64K blocks, if you will, you'll get an out of memory. So just change that default to be 4 times, which is 262. So I mean, needless to say, those are OS practices, but can it really affect perf is the question, right? Which we'll see in the demo. From a SQL perspective, we see affinitized CPUs on bare metal. Now, I really don't care on VMs as much because, I mean, you can't predict, I mean, unless you're affinitizing the VM to the actual processors, I mean, it's meaningless to actually affinitize SQL to, a virtual processor, if you will. On bare metal, it can give a performance boost for sure. TempDB, remember, it's post-install. Memory is an interesting thing here. So we're used to max server memory on Windows, and we're used to the fact that SQL grabs as much memory as possible. On the Linux side, by default, only 80% of the physical memory is actually visible as physical memory to the SQL process. So that's fine for a 16 gig box because 80%, okay, the OS needs some, and we have this other process or host extension layer which is outside of SQL Server. But if you take a 1 terabyte box or 512 gigabyte box, you're wasting a lot of memory keeping that at 80%. So that's a configuration option you can tune up to. So on a 1 terabyte box, totally fine going to 93% or so, from that perspective. That's something you might not realize that you're wasting memory because by default only 80% is seen. And then SP configure within SQL then does a subset of that. So that's within that 80, whatever SQL sees as physical memory that SP configure then, works on. Then be careful of this killer on Linux. So on Linux, effectively, if the OS is, if you disable, let's take for example, you disable swap, your swap file, and the OS is running low on resources or memory, it finds the process with the highest score or adjust score, and then kills it. Well, if it's a dedicated SQL box, I guarantee you that guy is going to be SQL Server.exe, or the SQL Server process, right? So configure swap appropriately, or there are articles where you can adjust the score to make SQL less of a candidate. That's not done out of the box. It's just you'll have to do a startup script type thing on the Linux side. We've had a couple of them, not on the bigger boxes, right? If it's dedicated in a bigger box, it's all good. When you try to put 3-4 things on a 32 gig box and something else can affect, that's where it comes more into play. You do a big rebuild index or something that chews up a ton of memory. Yeah. Oh, sorry.
Quick question. So, what's the replacement or similar to log pages in memory and setting the page size?
So that will potentially come. So there's some work being, okay, the question was what's the replacement, or is there lock pages in memory on Linux? And no, right now there isn't. So we're working on some work around NUMA and virtual processors and some other work in some of that scalability. There's nothing equivalent today. But we've not seen issues with paging, in testing so far. Now, most of the testing, the assumption of dedicated box still remains, right? It's not the assumption of, you put 5 other things in the box or 10 other things in the box, yeah?
There was that, what's the replacement for SQL IO?
What's the replacement for SQL IO? So SQL IO and SQL IO sim are always interesting beasts, right? SQL IO is deprecated long time ago. You're supposed to use disk PD on the Windows side, disk PD.
But the Windows side doesn't justify a SQL side. I need a tool where I can see through SQL what's happening. I use FIO and all those.
Okay, but SQL IO is not a SQL tool. It's not a SQL tool as in. Yeah, sure. No, but we deprecated SQL IO and we give you a set of parameters with disk PD to actually do throughput testing on Windows. SQL IO is not, because there are problems with SQL IO. You can't bank on it, is what I'm saying. Don't use it even on Windows. Use disk PD, and there are articles on how to use that for SQL Server, right? And then SQL IO sim is the other one, which is more about correctness and corruption patterns and so on and so forth, which is there on Windows. We will be bringing SQL IO sim to Linux, it's just not yet there. But for disk throughput stuff, there is no disk PD. So you bank on some of the, OSS tools, the throughput stuff. The correctness thing will bring something because.
How do you get the difference between, okay, disk has 50,000 IOPS available to it every second, but SQL is performing bad. SQL is waiting for disk. How do you differentiate between that? And we need
So, yeah.
on the SQL.
Yeah.
So
So let's take that offline. I'd be happy to chat because it's a bigger discussion than just Linux, right? So happy to address that. So the question was, how do you, if the I/O is good and SQL is still performing bad and showing, disk latency or with some sort of wait types, how do you troubleshoot that, right? Because the question of what is good I/O, or where are you looking at good I/O also is a big. It's a discussion we can have for an hour, but offline. So other common practices still exist, right? For the rest of the engine, your normal SQL practices still exist. There's a fix which on higher-end machines with multiple NUMA nodes would map wrong processes to the wrong node. So in CU1, we fixed that. This just for a reference. So let's look at this. So does this really actually makes any sense, or is this just smoke and mirrors? So let's look at that. Okay, so I'm going to go back to this machine. Hopefully it's doing something. Okay. So as you can see, we started some load. It's climbing up. Hopefully, it should do more than that. Not refreshing. Oops. Okay, I've not put it to the last 5 minutes. So let me put it to the last 5 minutes. Okay, so we see batch requests are actually climbing. So this is I think it's a 64 logical proc box. Memory is not, this workload doesn't require a lot of memory. It's just a, high throughput workload. So memory is not, could do it with 64 gigs. or less. So I mean, right here, I'm at about, what, 75, 74K, 75K batch requests per second, right? Averaging 75K batch requests per second, going to a RHEL machine. And so, so that's what I'm saying. So let's look at some of the tuned ADM stuff or some of those settings. I think I have it here. Zoom in, zoom in, zoom in. So tuned ADM list. And that so you have to install, so yum install tune would be required on RHEL. But once you do that, so you get the available profiles. So you see you have balanced, you have latency performance, network latency performance, a whole slew of them. For that matter, you can create your own profile, with the same settings that kind of they have. If you want to tweak something, you could have a SQL My Enterprise profile, right? And just use that on your RHEL servers. So tuned ADM active. So what is active currently? So current active profile is throughput performance. So I'm configured, so this takes care of some of the power management stuff, some of those other, sysctl options that we'd seen on the other slide as part of that. So what does this actually do? I think I lost. No, I lost it. Okay. Find / minus name, tuned. I don't remember the path at the top of my head. So, okay, it's user lab. So cat, so if you go to cd user /lib/tuned, you'll see the bunch of profiles. And they're nothing but a conf file. So I can do cd throughput performance and see that it's tune.conf. So if I look at tune.conf, vi tune.conf, so you see some CPU settings. You see the governor, CPU governor to be set as high performance, and CPU settings to say, okay, this is, don't put any balance settings. You have some disk settings to say read ahead is greater than 4096. And then you have some sysctl settings, here as well. So if you scroll down the list, you'd see VM swappiness is 10, some other dirty background ratio is 10, so on and so forth. So all these settings can individually be applied on Ubuntu too, so it just makes it convenient. Right, so what I'm going to do is on the fly, I'm going to actually change this tuned ADM profile balanced, right? I'm going to set it to balanced, profile to show you kind of the difference in some of the perf numbers. Let's go back to our graph. And it'll take like a couple, 30 seconds maybe. Hopefully not a whole lot more. But you can see this is already declining. And it doesn't quite look as bad unless you actually zoom into maybe some of this part. Right? So you go from something which was pretty steady, 75K, to somewhere closer to 65K. That could be the difference on some of the high performance workloads in terms of throughput. Right? So configure your settings, well from that perspective, because it can actually make a difference. More on bare metal than, anything else. So as you can see, there is a difference, a fundamental difference already. And I've not changed the workload. Workload was running, it was on the fly, I changed these performance settings. Okay, let's move on. So one of the things that people have often hit, actually, given the new LAMP stacks and stuff which are coming on SQL and Linux, is on the data warehouse or loading side, apps using Java. Java has an execute batch, and it's, when we say batch, as DBAs and SQL Server folks, we think it's kind of more analogous with bulk load, right? You're loading a batch of data. But that's not really it. The Java batch API effectively executes a batch of prepared statements. So if you do a batched insert, what it does is it prepares like a batch of 1,000, whatever your batch size is, singleton insert statements and submits it in a batch. So that's all good except when you're working with column store, right? So if you're working with column store, if you've seen any of the column store settings, and if you're not using column store on the warehouse side, please do, because the performance benefits are phenomenal. But we want your data to come in larger batches, actually 100,000 or more, 102,400 or more, so that you don't go into this delta row group. Rather, you go into a compressed row group directly. From that perspective, use SQL Server bulk copy class. So the JDBC driver, Microsoft JDBC driver does have a SQL bulk copy class, but also be aware of it, because some things like Spark, data frame write and all could not use bulk insert. So if you're doubting any of the bulk insert type performance on SQL on Linux, this is one gotcha you might have to look at from the app perspective. Profile it and see if it's coming in as what we expect as a bulk load, or if it's coming in more as a batch of singletons. Right, so the next one is performance data collection, or PSS diag. So how many of you have used PSS diag across? Okay, a fair amount of you. So I'm not going to go too much into this, because I have a couple other demos and I'll run out of time. But effectively, this gives you the same capability of PSS diag on Windows with Linux. So if you have end customers that you don't have a live monitoring system, you want a snapshot of their data to see their performance, and they ask you, hey, my server is running slow, and you need to collect data from them and actually get and post-process it, this actually will help you. This is also released to GitHub. There'll be a new build of it coming in another month. I started this originally, and the CSS folks are now actually owning this piece. And then you can do the analysis with SQL Server on Nexus as well. For certain pieces, it's already public. The DMV stuff just works, right? So if it's blocking, you'll see blocking. If it's things like that, latching, you'll see latch contention. So some of the OS parts are not there in Nexus, because that actually read perfmon files. So there will be some sort of converter released publicly. Internally, we have a way to convert those text collection files for IOStats and MP stats and all the other Linux counters, which are now collected in a flat file, into something you'll be able to pop open in perfmon for the Windows folks that are familiar with perfmon. Right? If not, there are other open source ways to actually parse, convert, use your scripting language of choice to visualize it. But it's a simple. So the collection looks like, I'm not going to collect and run it, but the collection effectively looks like this. So whether session state or whatever. So you have a set of files here, which are collected. So you have, IO top, you have, IO stat, you have machine config, and then you have all the DMV stuff that you're familiar with, which perf stats and, and such, which also give you the SQL view of the equation. So it's just, there's a conf file which tells you, give me the server I want to collect and things of that nature. The blog is there, has details, GitHub has details. If you have questions, email me, happy to help. Then we look at some advanced troubleshooting, and why is this kind of necessary? I want to showcase a couple of things, how to resolve call stacks on Linux. The other thing is, many of our scripts today actually ignore some of the preemptive weights, and so I'm going to show you some things that may be different, as you're comparing one versus another. So advanced troubleshooting. From a dumps perspective, on an exception, we still take a dump. If it's an exception within SQL Server, it's just as normal. If you get a dump file, open a case, with support, and they'll help look at it. We have an additional concept of a core dump, which is more of a native Linux dump. And the only reason I'm telling you this is not, from an analyzing perspective, because trust me, that'll be without symbols, you won't make much progress necessarily, as much as if you cannot connect to SQL Server, what type of data will you collect, right? I cannot connect to SQL Server. I cannot make a connection as a normal user. I cannot make a connection. Second step would be I would try to connect with dedicated admin to see if I'm out of threads. Everyone familiar with dedicated admin? If not, look up DAC. So that's one, it's a backdoor connection to an admin which is allowed to be made even if all my threads are consumed on the user space. So I can actually connect and look at what's going on my server. But if I can't connect with either of those two ways, I can either call CSS, or if I have to get back online, I can manually generate a core dump with Linux, and that's that core dump generates SQL dump.sh. And then restart my service and then have RCA done on Y later, right? So that's the goal of exposing you to this. And then the symbolization. So let's for this symbolization part, let's just look at a demo. It'll be easier than actually. So I have a database, so I have a Linux server. I'm connected to a Red Hat server. You guys can see the script, okay? And this is a simulated version of something, right? So this problem can happen in multiple things. So this is just drop and create a database. I've already done that. And while this is running, we'll go to the X events, but I'm going to collect a couple X events just in the interest of time. And run this. So this script simulates a problem, but let's assume I don't know the script, right? So I hit this wait tab, and there's this process in some application which is taking longer than it should. So let's say I'm migrating from Windows to Linux, so I'm comparing Windows to Linux because I'm deciding to move from an OSS database to SQL, and I want to compare both the platforms to see which one performs better, either way. So I run this script, and yes, it's taking a while. So I do my normal wait stats type stuff, right? I collect a snapshot of wait stats, and wait stats, as you know, is cumulative since the server restarts. So I need kind of 2 snapshots to make sense of kind of what was the wait during this particular interval. So I'm going to collect the second snapshot. And some of these ones are ignorable ones. From experience, we know log manager queue will be there on any system. This is wait for checkpoint offline. This is not a user thread, it's a background thread. I'm not too worried about it. But I see some preemptive type waits, right? 75 milliseconds average, 28 milliseconds average, delete file. These are not ones you often see on Windows. So what is a preemptive wait? A preemptive wait is when we, SQL OS has this concept of, it's a cooperative scheduler, right? So SQL threads, normal SQL work is done, so a thread is scheduled by SQL OS, and SQL OS then yields that thread to other threads. So it's not a preemptive, system. So when we're doing an OS call or a call that can take long or we don't have control over, we mark this thread as preemptive, so it gets under the, outside of the purview, if you will, from a schedulability from the SQL OS, and then, once that call has come back, we go non-preemptive, right? So that's a preemptive wait. So it usually maps to some sort of Windows API that we are calling. So there are a ton of preemptive waits, probably 100, 200 of them. So here we're seeing preemptive waits, and generally on the Windows side, preemptive wait means, okay, we'll track why that API was taking long and then try to address whatever it was that was happening. It could be a OS bottleneck, it could be, something else. So the kick is, so how do I know? So I know these other waits, but how do I know like what's the call, or like how do I get more information of what's the call stack? Or from Microsoft, even from us perspective, trying to help you or fix it. So I've created this, oh shoot, I should have actually, I did a huge mistake. I should have done watch live data, so I'm going to do this one more time. I'm collecting it in ring buffer, so it's gone. Apologies. Okay, so this will come up at some point. So I don't know if you saw, that took about 47 seconds or so, for that script to run. Shoot. Sorry guys, apologies. Is Is this producing? Okay, this is already produced, so the script is running. So if we look at this, if I just look at individual weights, right? So aggregated weights gives me one picture, but I can also use extended events to look at individual weights. Weight info is an extended event which gives me the weights within SQL Server, and then weight info external exposes all those preemptive weights. So there are two, kind of calls. So I'm going to stop this for a second. Stop. And look at one call. So, we see the speed is 56. We see a statement starting of create procedure. We see a statement completed. So let's just look at this one, block, if you will. Now note one thing, the times are different. The time is in microseconds for SP completed, but it's in milliseconds for wait info. So it's not as insignificant as it looks if you look at just the raw numbers. So you see for this one call, it's creating a memory optimized stored procedure. And you see a wait of preemptive OS create directory, which is 204 milliseconds, and 199 milliseconds again, and 2 preemptive OS delete files. So out of 2.5 seconds, about half a second is in preemptive waits, right? Not a big deal if you're creating one table, but think of a big database doing recovery, or think of a big database or big script creating a ton of objects. Time can be substantially more. So what can I do to see, okay, what are the code paths hit, or how do we actually debug that? So let's look at this wait info call stack thing. So what you can do is you can actually have an extended event on that. So now we know our wait type, right? So we know our wait type is, our top one will concentrate on, for example, is preemptive OS create directory. I can go to and create an extended event, and it's easier to probably show you in the UI. So I'm capturing wait info external, and then I have the filter predicate for my preemptive OS wait create directory. So I don't want to do this for all weights, right? So I've identified my top weight, and now for my top weight, I want to know, okay, what is in SQL Server? Why was it causing that weight? So for that weight, I actually go and create a histogram target. Right, so one more thing I forgot to actually mention. I can't hit configure. In the global fields, I've collected call stack. So every weight occurring, actually, it's going to collect a call stack on that weight, right? And I created a histogram target, and then I bucketize it based on that call stack. So I have, for every unique code path hit, I'll get the top code paths hit contributing to this, weight. So that's my extended event effectively, and in the weight type is just converted to a number, but effectively that's really it. So what I can do is then I can actually get those call stacks of my top weights, you see some module plus offset, right? So on the Windows side, it's a little bit easier to pull symbols and do things like that, but even on the Windows side, how do I actually make sense? SQL DK plus blah doesn't mean a whole lot to me. So there's a link on the slide deck, so if you guys get the slide deck, where Arvind, who's on my team, wrote this SQL call stack resolver. So what you can do is, Control 1. What you can do is you can paste that XC output that we have seen here, right? You can point to symbols, and he has instructions on how to get symbols for a particular version. I've downloaded them here so that I don't have to wait for the 500 MB of symbols to be downloaded. And then you can say resolve call stacks, and it actually gives you a call stack. Then you can do a search on the knowledge base article to see if there's a known fix, if there's a call stack known, so on and so forth. Is there a fix of that nature? Or if not, even when you contact support, you're much ahead of kind of where you would be if you just say it's slow. So here you see a couple things interesting. It's creating a table. It's getting my code gen directory. Even if I don't know, let's say I don't know the implementation of the code. Forget the implementation of the code. Even from function names, it's doing some sort of create an ACL directory, right? So And it's doing 10 times. Then I look at my script, which was, and I was creating 10 objects. So it's doing it 10 times. And then we know, it's doing it 10 times again. And, so all of these are very similar. It's all some creation and ACLs of some directory, right? So this is one of the things on the Linux side. I would say don't ignore your preemptive waits. And so we have a fix for this. Actually, it'll be coming up soon, and I'll show you, the version of the fix. But don't ignore your preemptive waits. A lot of the community scripts actually just ignores wait type equal to preemptive, percent. You might miss out a couple things like this. So we have a fix in the works, actually, and so I will show you the fixed actual version. Red hat. So this is we use MS SQL conf. It's under a trace flag. So opt MS SQL bin / MS SQL conf set trace flag 9944 on system CTL restart. Okay, so we're done with that. I'm going to rerun this guy. And actually, that same 47 seconds that took on Windows in this case, it was it had taken 7 seconds if I had to run it on Windows. So I have actually going to delete and recreate this database, just so we start from scratch, and rerun this. And let's look at waits again. Well, it's already done. I didn't even get a chance to look at waits. It's done in 5.2 seconds, right? So it was an issue we've seen with, we have a fast compile path now for something like in-memory OLTP, where we don't ACL on every create, and we optimize some of the ACLing, because the ACLing calls on Linux were taking longer. But it's not so much about this particular issue. What I wanted to focus was on, digging down more on a wait. So you had a question on IO path, for example, right? So any wait, you can dig down just another level to try to see if, we can get a call stack and what that is, right? And not necessarily for IO, because there are lots of layers under that, but, in other wait scenarios, you can get to the next level. So how am I doing on time? Okay. I have, 13 minutes. So let's move on to HA. Oh, my animation was an epic fail. On availability groups in Linux, so we do have availability groups in Linux. I wanted to walk through a couple of the gotchas and expose you to something new in CU1. So we have a concept. We have two new cluster types, if you will, and this is new to 2017 in general, right? We have a cluster type called external, which is used explicitly on Linux, not on Windows. And so that's when you are banking on an external clustering solution, because our AG solution on Linux, does bank on the pacemaker clustering solution to manage quorum and things like that. We don't have Windows clustering actually, working on Linux, of course, and so, pacemaker is it. So on the RTM bits, which is the release bits, because there is no concept, so on Windows you can have two replicas with a file share witness, and file share witness does have some amount of quorum, right? It has configuration info, so on and so forth. When we released Linux, or we discovered later in the development cycle that on Linux you actually needed 3 copies of the databases. You needed a third node to maintain quorum, and that third node needed to have a full sync replica, which means not only from a licensing perspective you were at a disadvantage, as well as from a hardware perspective you needed a bigger box, right, because it's a full copy of the data. And now there's a performance penalty of actually having sync commit to 2 copies. So that was the RTM story. CU1, which just shipped last week, enables you to do this with 2 sync replicas. You can have, but you need a third replica, a third SQL Server instance that can be an express edition, which only stores configuration info, because again, there's no file share witness equivalent in pacemaker. So we need a third person to break a tie in a quorum so that you don't run into split brain type situations, right? So if you have a primary and a secondary and there's nobody else to arbitrate, that's the problem, yeah? That is a great question. I think it should be able to. I don't see why not. So the third instance, we'll look at it. I have not literally tested it. I will test soon after. I'll get back to you. So the third machine also has to be part of the pacemaker cluster and part of the AG. I don't see why it couldn't if you were on the same pacemaker cluster. That would be the limitation, right? So could it be used for an AG in configuration mode for another, set of AGs? Yeah, sure. But I don't think it could be part of two pacemaker clusters. So if you have multiple availability groups, yeah, so that's the problem, yeah. The multiple availability groups within the same cluster, perhaps, but not otherwise. So anyways. Yep. So no, that's not a replica. So the Express Edition thing only has configuration. To think of it more as a witness, a file share witnessy type thing. It's not a file share witness, but think of it, it has just metadata of some configuration and can arbitrate quorum or participate kind of in the quorum. It doesn't have any of the data. Now if you went to GA solution, it would require data. So that's the CU1 thing which is just introduced. And then you have cluster type equal to none, which actually enables a couple scenarios. It doesn't require to have the cluster. You can have, an AG without a cluster totally. It's, use cases if you want to scale out your reads, you don't care about, automatic failover or quorum or things of that nature. That's one thing. You can even have it cross-platform, spanning Windows and Linux, in case you want to do, some sort of migration or failover, quick migration type scenario. But of course, in that case, you would have to have 2017 on Windows to anything future in Linux or 2017 on Linux. You won't work from back things. So let's look at the demo here. Okay. Quick demo and then I'll be done. So here's what that looks like. So I have it configured already. And I'll talk about Stoneit in a second too, because that's actually quite important. So I have, 3 nodes here, and as you can see, one of them here, I don't zoom it on a VM is not always great. You see this node is configuration only, right? So failover mode is external here, your seeding mode is external, they're synchronized, but this third node is configuration only. So you don't see the database on 04, it's only on 02 and 03. Right, not on 04. So that's, what that looks like. So let's look at, I'm going to cheat again. What was I supposed to show? Okay, so let's look at the cluster from the pacemaker side. So we see a couple of things here. We see, 3 nodes. You have 02, 03, 04, PCS status. We see the master currently is 02, so the primary is 02, right? And the slaves are 03 or 04. So things like failovers when you have external cluster has to be done from the clustering software. Okay, this is not a tightly coupled like in Windows, and the reason is extensibility. Potentially you could, have another clustering solution supported and not be limited to pacemaker, down the future. But all the failover type stuff has to be done from PCS or the GUI for pacemaker. So here your master, here your slaves, and there is a GUI also from a Red Hat perspective. HA cluster. Hope my password is correct. So the Red Hat GUI, I like it more as a read-only view into my topology and configuration as much as I get scared to click a button because I have no idea what it's going to do. and it's not very good in status and telling me I did this or, this was successful or whatever else. So I have, my cluster, unable to connect to the cluster. That's not good. anyways, I will let you guys explore the GUI. So just know that there is a GUI. It's on port, the default is port 2224 here. If you look at Red Hat documentation, you will see that. So there's a GUI to show you, nodes and so on and so forth. I don't know why it's not behaving right now. Yeah, I know, but maybe my HTTP service is down or something. Anyways, so that's the second thing. The other, key point with pacemaker and clusters is to go to production, you need to have Stoneit configured, which is, a fencing mechanism. So if a node is down effectively, pacemaker, Stoneit shoot the other node in the head, effectively. So it fences that node from, possibilities in the cluster. And this Stoneit is a little bit of a tricky thing because Stoneit depends on your underlying hardware. So what that means is if you have, bare metal, there's Stoneit agents for ILO, ILO2, ILO3, which connects to your power supply and sees status on the box if it's up or not. If it's VMware, there's a VMware, Stoneit agent. If it's KVM, there's a KVM Stoneit agent. We don't have HA in the cloud right now with Pacemaker. Pacemaker doesn't have a supported Stoneit agent in the cloud. We're working with SLES. SLES is the first one, which is there for SAP. So we're trying to get them to support pretty shortly. But that's ongoing work, right? So, but to go to production, you require Stoneit. And while configuring Stoneit is actually a bit tricky. And so a couple tips there, or one tip is please test your Stoneit agents outside. So if you go to user bin, fence asterisk, these are actually all your Stoneit agents. You can go to the code, they're Python scripts effectively, right? So these are your Stoneit agents which exist. So there's APC, there's ILO2, ILO3, ILO4, so on and so forth. There's VMware SOAP. So depending on your platform, it's very dependent to the platform you run, unlike, some other stuff. So you absolutely should actually test, and this is a way, so you can invoke these, Stoneit agents manually before you actually add them to the cluster. And the reason why is if you add them to the cluster and they're not functioning as they're supposed to, debugging or figuring out why becomes really, really difficult. And you'll get the cluster bouncing and stuff like that. So make sure Stoneit agent parameters are correct. So an easy way is, so actually you can do the Stoneit agent -h to see a quick set of options. And gives you, some options of what they expect as parameters. So as you can see, I copied this here, and effectively it's getting a status, and it says that the machine is on. So it's more at the machine level, is it on, is it off, is it responding, so on and so forth. So Stoneit is important from that perspective. I am running out of time. I want to keep 2 minutes for questions. I had a little bit extra of a demo from a troubleshooting perspective from Pacemaker, but I want to leave a couple minutes for questions if there are, and then we'll, take any other questions offline, no problem. Questions at this point? Yep. Oh, are we? Oh, I'm sorry. Okay, so we'll wrap it up. I'll take questions offline. Thank you.